Okay, several people have asked me how I built this. Figured a video would be the easiest way to explain. So we'll start with the housing. It's just aluminum. It is not quite an 1/8 inch aluminum. I think it's a 16 gauge aluminum. And this is a bend, and there's a bend on the other corner, so it's kind of a U-shaped bend. And then there's a top, and the bottom is a separate sheet in the back. So I just bought all that aluminum from a Metal Mart store locally. And then I cut with a Dremel tool, if I remember, these slots and made a little tool to bend the grill. You could just cut the square out and buy a grill. I mean, those are things I didn't think of at the time, but so you have vent there. This is where air flows in. I'm doing a video for YouTube so people know how to build this. Yeah. And then there's a space heater that I just pulled the insides out of here for the fan and the heat element. So it can pull air in from that vent into this chamber here and then into the heat chamber. And then there's an out vent there. And then the ventilation down there is just to keep these components cool. This is a solid state relay that I got off of Auburn Instruments. It's a 25 amp solid state relay. This is a 13 RPM geared motor that I got off of Grainger. I want to say it's 1/4 horsepower. Pretty sure that's what I remember. 1/4 horsepower motor, 13 RPM. And it's just got some mounting holes, which then there's the shaft there. And I just ground a flat on it. You can see there. That's a stainless steel wing nut with a set screw that I drilled and tapped the hole there so that that can set onto the shaft, and that's what engages the bowl. And that's worked really well. And then I bought another just little desk fan that I pulled the fan out of. Just bent up a metal bracket here to help keep that motor cool. It is a continuous duty motor, but I just like to be sure that things are going to stay cool enough, so I put an extra fan on there, and then it comes with a fan. You can see I also put slots down here so it has airflow. The solid state relay has heat sink on it, on the bottom part there where it contacts aluminum to help keep it cool. So yeah, and then I've got just a power cord here coming out. Hawk that off of something else. As far as the wiring goes, I mean, you just get the components, and you'll need to look at the schematics for the relay. And for the temperature controller, you can see the bottom of it hanging down in there. And this is the temperature controller I got here. Let that focus. There you go. Got that from Auburn Instruments as well for $36. There's better, obviously much better controllers out there, but it does the job, and I was trying to keep this lower cost. A couple of switches, I'll show you what those do in a minute. And then you've got a thermocouple here, K-type thermocouple from Auburn Instruments as well. So I got my electronics control stuff from Auburn Instruments, and the other stuff I got just at like hardware stores and stuff. Okay, so the dimensions of the box are right here. It is 14 inches along the bottom there, 12 inches high, and 19 inches long. This chamber is approximately 7 inches by 5.5 inches, and then this would be the difference of that, 13.5. And then this bottom chamber is also the difference there from the total dimension to that, roughly, so about 5 inches here. So you just got to make sure you have clearance for that fan and the motor and how it mounts. I have 1/2 inch flanges everywhere to give it something to screw to and stiffness. So that's the housing, just a sheet metal. I took it to a heating and air conditioning place. I laid it all out with some tape, masking tape, like where all the bends and cuts should be. And then they did it for 15 bucks. I don't know what people will do it for, but that's what the place did it for here, just to bend it up. I had already brought the material, it was already cut out. It'd probably be worth it to just take them, the the metal and your plans maybe even, and see what they'd do for that. That'd save you all the cutting and all that kind of stuff. Maybe they'd bend you up a box that worked for you for $50 or something, and that'd probably be worth it. But anyways, that was great for getting really nice tight bends. Okay, these I'll put it together. I'm going to pause here. I'll put it together somewhat, and I'll show you some of the other components. Okay, I changed my mind. I figured it'd be more instructive to show you as I put it together. Just one other thing. This is that 1/4 inch or 3/8 inch, I guess, high performance insulation. I can't remember exactly what it's called, but I got it off of McMaster's. Just some really good insulation to keep this area warm, the awning arm, and keep the rest of the housing from getting hot, because aluminum obviously is really conductive heat-wise and electrically. On that note, make sure you ground your box. Get an electrician or something. My brother's an electrician, so he helped me make sure I didn't do anything dangerous. But this isn't just for educational purposes. I'll say that, not meant to instruct people. So I'm not liable for you if you screw something up. That's up to you. But just thought I'd share what it is I have done. This is the bowl. I got these at Walmart back in the day. And I bought several because Walmart changes its inventory frequently. So this housing is specific to these bowls. I didn't want to end up not being able to have replacements. So I bought 4 or 5 all at the same time. So basically you have an aluminum block here that I drilled and tapped. Just a couple holes, pretty simple. And down right in between the bowl and the block, sorry it's blurry, there's a 1/8 inch silicone that I just punched out. It's food grade, FDA approved off McMaster's silicone, and I just punched holes for those two things, and then that creates a watertight seal. So then I use some stainless steel screws and washers and just punch 2 holes through the bowl. They thread through there and go through the silicone, and as they clamp down on that aluminum block, it squishes that silicone and makes a really nice seal. And then that you'll see. Oh, here people have asked about the rollers. This is how I did my rollers. These are shower rollers. I figured they'd be good because they are made for wet environments. So I've got 8 of them alternating here. So you've got one that bear the weight and then another one that controls the position of the bowl. So I just alternate back and forth. And for that you can see I just bent flanges down from the existing aluminum and screwed into that, and then here was just a simple hole and screw into that. So I put the bowl in, those wheels, it just rides on that lip of the bowl, and then you can see down here, I'll get the flashlight, you can see hopefully, there you go, I'll let that focus, how that aluminum engages the wing nut. And I'll flip it on here. One of these controls the motor for the bowl, and the other one controls the heat. You can see how that just engages that. And I just wanted something that was drop in, really simple. You don't have to align anything really, just drop it in and it catches it. Now to the spatula. This is food grade polyethylene. High density polyethylene, I think is what I got. And I used snow actually to capture the form of the bowl. And then I could slice the snow in half and then with a piece of cardboard trace out the outline. So I got a pretty exact fit. So you could think of other things besides snow to fit that form, maybe sand or Play-Doh or something, I don't know. But that's how I did it. Happened to have snow outside when I was building this. I did eventually cut away a portion of it and add this silicone scraper, which again, I'm using stainless steel anywhere where it's going to come in contact with food. There's some more of that food grade silicone that I cut to be a scraper. And then these are flow-through holes, 1/2 inch or 3/8. It's not really significant, but And then I kind of used a lamination type idea here where I just bolted some heavier stock polyethylene to create this cross section here. And then you've got these two notches in the end and these holes. The holes are for the thermocouple. I'll show you how that works. So this sets in here. You can see it just slides over these posts here. And that locks it. And that is just, again, that's an aluminum threaded post. Got that from Ace Hardware, and some stainless steel stuff here just to make it stiffer. And then that just bolts through the bottom there. Okay. And it allows, you put solid chocolate chunks on this side, and as it melts, there's a gap and it allows the liquid to flow to the other side. And then this scraper keeps the liquid pretty much on the other half of the bowl. So solid chocolate here, liquid chocolate ends up over here. And then you can put this thermocouple over here so that it's taking the temperature of the liquid chocolate. And that's what this controller is using to change the cycling on and off of the heat element. The fan on this always stays running, but the heat element cycles on and off based on this thermocouple and that temperature controller controlling it. And then it's got these two knobs here that just screw in right there. And that secures it. One there and one over here. Just like that. And then, of course, there's, again, insulation on the back of this that lines up with that box. This just goes on there and has some screws. Nothing real fancy there going on. So we're about finished here. This hole, early on, to regulate things better, because there's no melted chocolate to measure at first, I'll stick the thermocouple in there. And that is measuring the temperature of the air. And so this thing doesn't like go crazy trying to really overheat, because out here it's just measuring room temperature. It doesn't have any liquid chocolate yet. So you stick that in there until you get some liquid chocolate going. Then you can transfer to there and then measure the chocolate from there on out. Like I mentioned, you got one control for the motor. Or sorry, that one's for the heater. And this control you can read. You can set the temperature and what you want it to be, and you can it will adjust to that. I mean, there's a bunch of stuff you can do with it. You can read the instructions on that. You can hear the heater, the space heater going, and then, like I said, then you've got independent control. Independent control of the motor and the heat element, so you can preheat and stir, and you can kill the heat and leave the motor running. You can do whatever you want there. I thought that was nice to have that separate. Maybe that's how it is everywhere, I don't know. But and then that's just a little clip there to, got that from Ace, kind of modified it. It was some kind of cable thing with a nail to like tie down like wires, and you like nail it in. I just replaced it with a screw and fit that coupler really well. So hopefully that answers all your questions. Like I said, use stainless steel or food grade stuff anywhere that's going to come in contact with food. I used aluminum elsewhere because it's non-corrosive, cheap, easy to work with. And then you saw the electronics, and that element I just bolted, drilled some holes through the plastic and bolted it through there. But that's going to be just somewhat dependent on the space. You just kind of have to figure that out a little bit. But hopefully that should get you where you need to go and answer your questions. All right, thanks.